Good morning, everyone, and welcome to our workshop on data quality assessment for risk assessment purposes. Obviously, using high quality data is essential for risk assessment of chemical substances, and the engineered nanomaterials are not an exception to this. It is very important for risk assessors to be aware of the quality of the data that they use. But such information is not always available. To address this issue, the European Horizon 2020 project Gracious proposed a methodology to facilitate evaluation of quality and completeness of nanosafety datasets. This methodology is tailored specifically to physical, chemical, and hazard data for nanomaterials. So it is not focusing on release or exposure data. The methodology is unique in the sense that it can automatically assess data quality and completeness, starting from the available data or metadata. And therefore, it doesn't rely much on expert judgment. Which can be a useful feature. Our goal is to further advance the methodology in the H2020 Go for Nano project and implement it as a functionality of the eNanoMapper database to enable real-time analysis of each dataset that is included in the database. However, to achieve this, we need your help. This is why we're organizing this virtual workshop to present our approach and collect expert opinion on several aspects of the methodology. The workshop is organized in 4 parts. First, we'll start with a presentation by Dr. Hubert Rauscher from the Joint Research Center of the European Commission. He will introduce the concept of data quality for risk assessment purposes and will explain why we need to progress further in this area. Then Dr. Gian Pietro Bassei from the company Green Decision will present the methodology for assessing quality and completeness of physical, chemical, and hazard nanosafety datasets. This will be the main focus of today's workshop. It will be an interactive session where we're going to use Slido polls to collect your opinions on different aspects of the methodology. Our third presenter today is Dr. Nina Zhilaskova from the company Idea Consult. She will demonstrate how parts of the methodology were already implemented in the eNanoMapper database. This will be followed by a general open discussion with all of you before we complete the workshop with a summary and conclusions. During the workshop, everyone will be muted. We would use Slido polls to collect your opinions on different aspects of our methodology and how it is implemented. And then in the general discussion, I would kindly ask you to post your questions in the chat, and we would you will be able then to switch on your microphones and express your opinions. With this, I'm now leaving the floor to Hubert for his presentation.
Yeah, good morning, everyone. I'm Hubert Rauscher from the European Commission's Joint Research Center, and I would like to give you a little introduction into the topic. I would also like to show you some challenges that we face when we try to objectively assess the data quality of nanomaterials. And I'm not intending to give you a big presentation on data quality. Time doesn't allow for that. Rather, I would like to give you a kind of an anecdotal introduction with a case study from the Gracious project that focuses on the data completeness, which is one aspect of data quality. So to indicate the problems that we have and that leads the way how to tackle them, and that led the way to our to the methodology that is presented then thereafter. Change the slide here. So, okay. So, to start with, this is in the framework of the Gracious Horizon 2020 project Gracious that is developing and testing a framework for grouping and read across nanoforms. And that for that purpose, I don't want to say anything more about that, about the framework, but for the purpose of potential grouping and read across, detailed data on nanoforms of high quality are required. So for this, to assess the quality of the data, some set of data quality criteria is needed, and also a methodology how to apply this criteria and how to assess the data quality. And as we are dealing with potentially a very high number of nanoforms, all the required steps to assess the data quality, they should be automatized. So it should not be necessary to do a lot of manual work, because for when you're dealing with hundreds and thousands of nanoforms, that doesn't work. Also, automatization will reduce the need of expert judgment to the minimum. And also the goal was then to implement that methodology in the Gracious database that will be presented by the other speakers. And of course, there are approaches to assess the data quality are existing, and several aspects, so the completeness, the reliability, the relevance, and the adequacy. So several approaches exist to assess this, and for specific purposes, for example, the well-known Klimisch scores. But for the reasons that I hope that will become clear during the workshop, they do not exactly meet the requirements as stated now here in that introductory slide. So the data quality, generally speaking, is a measure of the usefulness, clarity, and the correctness of data. And the data completeness is a measure of the availability of the necessary data and the metadata. And or in other words, it describes whether the data that are needed are also present. So that's it, very simple. And also, the concept that is often seen in connection with the data quality are these FAIR principles of data. And they have been the FAIR principle, probably you know them. They are data, they are describing certain quality of data. So data are fair if they are obtained according to standardized test protocols, when they are reported in a harmonized format that requires a minimum set of information, when they are curated and stored in structured repositories, and when they are available for integration and reuse. And these are the FAIR principles: findable, accessible, interoperable, reusable, that have been published in 2016 by Wilkinson et al. Now, regarding the fairness of data for nanosafety, several databases have been analyzed in a recent publication by Nina Ilyaskova et al. very recently in this Nature Nanotechnology paper, and they analyze certain databases and assess the fairness of these databases. I have to say that the FAIR principles themselves, they do not provide an automatic means for the data quality assessment. But I personally believe if data really follow the FAIR principles in a deeply teleological sense, they are also of high quality, but they can be discussed. Anyway, I would like to concentrate now on one of these criteria. This is now framed in red. So the data are fair and also complete if they're reported in common harmonized format requiring a minimum set of information. So that is the completeness of the data. Now, in the project, in the Gracious project, the completeness of the data had to be analyzed and assessed for several reasons. So in the project, there was the need for high quality basic information on nanoforms. And here this example refers to physical-chemical properties that you see here in this circle. So the physical-chemical properties that are in the red frames, they are really important for nanosafety assessment because, and they are also important for regulatory purposes because those are required by REACH, according to REACH, for identification of nanoforms. And the green, the properties in the green fields are recommended by the ECHA for grouping and read-across purposes to be used for that. So therefore, they're really important. And the Gracious had the need to have this data and to have high quality data. So I use this as an example, of course, but other projects addressing aspects of nanosafety probably have the similar needs. Going back to Gracious. In Gracious, now there was the task to collect data about these properties on two types of materials. On the one hand, so-called representative test materials, so-called benchmark materials, they are assumed to be already data rich with a lot of information accessible because they have been studied in various other projects. So these are materials such as the silica NM200 or barium sulfide NM220 from the JRC repository used in many projects, data collected, and they are available in databases, for example, in the eNanoMapper instances of projects. And the second group of materials is the case study materials. So these are other materials, non-data rich materials, so data had to be generated in the project itself. So there were some questions to answer for the Gracious project. If we need data from potentially data-rich materials, can existing data on these materials be reused? So can we make use of the data that have been obtained in other projects, made available to the Gracious project, and use them for the purposes of the Gracious project? And the second question is, for the case study materials, which metadata and which data are exactly required for this case study materials in order to have a harmonized format that is harmonized across the entire project, across all partners, so that the partners know what data to report for which properties and what metadata. So these are the questions then. Then in answering this question, we made use of previous work of other projects, of the NanoRec project, here specifically. Because in the NanoRec project, there were templates developed because, of course, it was realized in that big project that the reporting of complete metadata is fundamental for the safety of assessment of nanomaterials. And so in that project, the so-called harmonized nanorec templates have been developed for several properties, and other templates have been developed in Gracious where there were no templates available from nanorec. So all these are publicly available in the on the web pages that you can read on the bottom of this slide. So these templates were developed to ensure the comparability, reproducibility, and reuse of the test results, also as a part of the fair data principle. And the templates are very simple. So they are spreadsheets that contain several sections, template sections that you can see here. So the sample information, the sample preparation, method and instrument, results, and SOPs. And for each of these sections, there's a number of information items required for where you can introduce the data and the required metadata. And now, for every, you can report every experiment in one row of this template, inserting the required data and metadata to get a complete information on data and metadata for specific purposes. So each of these templates, they refer to a specific property, for example, zeta potential, and a specific technique that is used to obtain this property. For example, size distribution by electron microscopy. For each experiment, it requires a list of information items, and all of these data are reported in the same row. So these are Excel sheets, and the Gracious partners for the case study materials were asked to provide the basic physical-chemical data on these materials using these templates and upload them then to the Gracious eNano Mapper database. So how is it done then? For the representative test materials, so for the case study materials, partners were asked to use the templates and report them. For the already existing data, these representative test materials, data-rich materials, these data were extracted from the project-specific instances of the eNano Mapper database. So they were extracted. It turned out they had to be cleaned. I'll tell you afterward what that means, and then transferred into the templates of nanorec and Gracious. So these data were made available from the other projects, and they are, as many of them are also publicly available. So then it was possible by extracting the data on the templates, and also by using the data provided by the Gracious partners on the case study materials, all in this presented in these templates, to analyze the completeness of the data on this nanomaterials that were of regulatory relevance, as I said before. By just simply analyzing, is everything reported that the templates require? For the representative test materials that were extracted from existing data, it turned out that curation and correction was really essential, because it turned out that there were many, let's say, errors or items reported in the wrong field and so on. So it was a lot of work to curate this data and then to transfer them to the correct templates. So now then, we can, when we extract the data and when we collect the data from the Gracious partners, we can compare them with the requirements for the templates. How does it look like? So this is an example. You don't need to read the data, but you just see that this is an example of a template, in that case zeta potential template, where you have the different sections here, and here you have already data, in that case provided by a partner and filled in these templates. So that the individual information items are in the individual fields here. And how now to check objectively how complete these data are. So some you see some fields are empty. What is the completeness of this data? Now we introduce this completeness score. That simply means we divide the number of the items reported in row I, so the data that are there, by the number of the items required. So that means if everything is reported that the templates require, we get a completeness score of 1. If nothing is reported, we get a completeness score of 0. So the completeness score here is between 0 and 1. Now the good thing about this is that this completeness score, with this completeness score, we have a measure of the degree of completeness of a defined set of metadata. And this completeness score is really flexible because we can calculate the completeness score for a single measurement, so meaning for a single row, if everything is complete, or just for a subset of the metadata. For example, is the sample information complete only, so we can calculate completeness scores for every single section of the template. Or we can calculate a completeness score for the whole nanomaterial across a specific set of properties, or even across sets of nanomaterials. So it's very flexible to assess the completeness of the data in several ways. Now, this is the completeness score. And when we now analyze the data that were already present in the database, coming from other projects, seemingly data-rich materials, we find the following. So we calculate here for the materials silver, barium sulfate, cerium oxide, and so on, that were used as benchmark materials in the project, the completeness scores of these basic physicochemical properties that are really necessary for regulatory purposes, such as composition, crystallinity, particle shape, and so on, for specific techniques. And we get completeness scores. So by the way, the red fields mean nothing is reported, so that these data are not existing, maybe they are not measured. But when they are reported, they are in the green fields, the completeness score, I would say they are not really high. They clearly have the potential for improvement. Because let's say, for example, barium sulfate, when we do the completeness score across all these physicochemical properties, we land at an average completeness score 0.54. And when we for example, check for a completeness score of dynamic light scattering across these 5 materials, we land at an average completeness score of 0.25. But this is quite irritating, I would say, but that is the case. You can read that in that publication. So when we, however, look at the case data for the case study materials, where the data providers from the project were explicitly asked to use these templates and provide the data in an orderly form in the templates, the completeness scores are not 1, but they increase drastically as compared to already existing data. So this table was made at a specific stage of the project, so not all data were available, and the completeness scores were only calculated and the averages for the green fields. So that is, it increases drastically when you have these agreed templates. Now I already come to the conclusion of my little introduction. Of course, we know that the data and metadata completeness is an important aspect of data quality. The data quality can be quantified by completeness scores that are based on standardized templates, here in that case, Nanoreg and Gracious templates. When the reporting templates that are there, and they were, by the way, there already for the other projects, but when they are properly used, the completeness scores increase drastically, I would say. But even if the databases have a high level of fairness, and what is that? I would recommend to have a look at the Nature Nanotech paper by Nina Iliaskova et al. That analyze the fairness scores of different databases. So the fairness score is I would say it is a potential that the database offers to the users that when they report their data in a good way, they are fair and maybe also high quality. But even if the databases have a high level of fairness, implicit fairness, there's the need for data quality assessment and data quality assurance of the actual data that are uploaded in the database. As you have seen, the templates are based on spreadsheets. Therefore, this means the calculation of the completeness scores can be easily implemented in any database as an automatic functionality. And you will see more about this in the presentation by Nina, the third presentation. And I have limited myself on the data completeness, but this approach with the scores, this approach can be further developed in a full methodology that allows to automatically, rapidly, and objectively assess any aspect of data quality. And the proposal that was developed in that project will be presented to you by Gianpietro Basei in the next presentation. I would like to stop here now and thank you for your attention. If you have one question, I'm happy to answer that. Otherwise, I will give the floor to back to Daniel. Thank you.
Thank you very much, Hubert, for this excellent presentation. So now we can move to our next presentation, which is about the actual methodology for assessing data completeness and combining it with other relevant data quality criteria for assessing the quality of physical, chemical, and hazard data. And our next speaker is Dr. Gianpietro Basei from Green Decision.
Hi everyone, good morning, and thank you for joining this workshop. This presentation, as introduced by both Daniel and Hubert, is about the data quality and completeness assessment methodology that we developed or we are developing in Gracious, and that will continue also in Go for Nano project. In the Go for Nano project, this session is interactive because we will ask you to answer some questions related to the methodology that I'm going to present. And for this exercise, we will use Slido. There will be the link in the chat, and you can click it and answer the questions once they arrive. There will be several questions for you. So, which were the objectives of this methodology? Daniel and also Hubert already said something about that. Our objectives were to develop methodology for assessing data quality and completeness with a specific goal of addressing regulatory risk assessment purposes. And furthermore, we had the goal to implement the methodology in the NanoMapper database. And also, this methodology was partially implemented in a weight of evidence approach that is currently under review. The focus of the methodology is on physico-chemical, of course, since it's tailored to regulatory risk assessment, focuses on physical-chemical properties and on ecotoxicological data. And we wanted to have this quality and completeness assessed in such a way that all the steps required by the methodology are automatized, thus having a minimal reliance on expert judgment. So, as I said to you, we have this Slido section. We already have the first question, which are just to understand who you are and which you can find the link actually in the chat to understand who you are and whether you need or not risk assessment, data quality evaluation in your daily work. So the first question is which group do you represent? We have several options to select. I will wait. We will wait a few seconds for you to log in and to answer the questions. Okay, I see some interaction, so let's wait a couple of seconds before going to the next question. By the way, you can see in the screen that there are the live results. So apparently most of you are from academia or research institutes. There is 20% of you which comes from regulator agencies, consultancy industries, no one from small and medium enterprises. And there is another, we will have a question for you after this one. Let's wait a little bit more. Okay, I think we can go to the next question. So if you selected other, I think it already asked to you. Scientific association, okay, NGO, okay, so only two answers about that. Okay, perfect. Then we can go to the next questions. Not governmental, yeah. Is risk assessment part of your daily activities, yes or not? Okay, so almost 64% of you is working on a daily basis, or at least very often with risk assessment related activities. I think we can see a little bit of interaction still, but in a couple of seconds, I think we can go to the next question. Okay, so do you need data quality assessment for your daily activities or not? Okay, so most of you needs data quality assessment. So hopefully you will find this methodology interesting and useful for your work. I think we can go to the next question, which asks for which task is data quality assessment needed in your work. Here you can answer more. You can answer more than one answer if you want, as far as I remember. So there are a lot of different tasks which requires data quality assessments. Most of the answers are related to hazard assessment, risk assessment, or yeah, both for ecological data and toxicological data, ecotoxicological, sorry, data. But there are also some need for dissemination. I see standardization, regulation, improving fairness, physical, chemical. Okay, yeah. So yeah, there are a lot of tasks that requires data quality assessment. As I said before, our methodology is tailored to risk assessment purposes and to specifically we are focusing on physical, chemical, but the final goal is to evaluate ecotoxicological and toxicological data. So I think we can go back to the slides. Probably the question will remain open, but I don't know if someone has other input to insert. So which was the approach that we followed to develop this methodology? First of all, we started with a literature review of the current data quality and completeness criteria and approaches. And we developed this, and we created this working group to develop the methodology for assessing data quality and completeness. Then the final step, which is currently ongoing and will be part of it, once the methodology will be fully implemented, fully defined, and yeah, it will be implemented at least partially in the Nanomapper database. Okay, next slide, please. So after reviewing the existing criteria, what we found is that what we selected as criteria for evaluating data quality are data completeness, which refers to the degree to which all required metadata in a dataset are available. And this is basically what was presented to you by Hubert, and which was the starting point of which is actually the starting point of our methodology and of our work. Then we selected data reliability, which measures if the study has been conducted in a reliable manner. Data relevance, which measures if a study was conducted using agreed, let's say, standard protocols and procedures. And data adequacy, which defines the usefulness of the data for the specific task, in this case, risk assessment purposes. Next question, next slide, please. So the first criteria, going a little bit more in detail, is data completeness, and it is basically what was presented to you by Hubert. It is based on the evaluation of 11 relevant physical chemical properties, which are either required by REACH for nanoform identification or recommended by ECHA for grouping and read across. Yeah, and that can be measured basically using different techniques, and each of these techniques will add as a specific data reporting template, as Hubert displayed to you. Next slide, please, Stella. Completeness score is computed as the number of items or parameters reported on a template divided by the number of items, or parameters required by the template. And the final completeness score, as we defined in this methodology, is the average between the completeness scores of each of these templates. Furthermore, we propose to adopt the same approach also for evaluating completeness with respect to ecotoxicological templates. This is because together with the physical chemical templates for reporting data in a Nanomapper, or in general, there are also templates, of course, for ecotoxicological endpoints, and this is an example of a template for ecotoxicological test, which is only partially filled up for two studies. Okay, next slide, please. The process of evaluating data completeness can be automatized directly in templates, and indeed it has already been implemented in the development version of the database. As you can see in the figure, so the bottom part of the second figure, let's say the bottom part of the figure, and as Nina will explain better to you in the next presentation. We still have some open issue or open things to decide, because it is possible to wait, not to give a weight to each of the parameters, the same weight to each of the parameter, but what we can do is to weight the parameters which are for expert judgment considered to be the most important one can be weighted differently. In this way, we will just need to modify the computation of completeness by considering a weighted sum of and then a weighted completeness. So next slide. I think we have the second part of the Slido session here. So please go back to Slido. This question is related to both my presentation and the presentation of Hubert. Do you agree with the proposed procedure for assessing data completeness? Yes, partially or not. This includes also the evaluation of completeness for ecotoxicological templates and not only the physical chemical templates. So let's wait. So I see that there are most of you agree with our methodology for a set procedure, let's say, for assessing data completeness, but there are some, I think, one or two of you that do not agree with us or only partially agree with us. I think in the slide, if I remember correctly, there is the opportunity to explain why or to write what is missing in the methodology. So it will be important for us to understand what we are not considering. Okay, I think we can go to the results. So partial out, which changes will you propose to procedure for assessing data completeness, representativeness? The amount of data is always increasing. How do you include this in your definition? This is a nice question, something we should need to address. The method is dependent on the database or requirements. Who decided these were requirements and so on? The same data may have multiple data completeness score. Well, the templates are based on are actually quite how to say well known in the Nanosafety community. So that's why we started from this, and of course because we rely on data in Nanomapper. But this can be of course yeah, they are also based on the OECD ones, but basically the same approach can be used starting by other templates in principle. I think methodology looks good, but interested in seeing a larger set of data sets analyzed and specifically also with link to different databases. This is also a nice point. Good start, but requires intimate communication, dialogue. Yes, of course. So thank you for your comments, which will be, of course, a good starting point to improve and to explain better our methodology. So I think we can go to the next question. Should each parameter or group of parameters be weighted, or should we give the same weight to each parameter? So, yes, so same weight. If you think that each parameter should have the same weight, the answer to give is no, otherwise the answer is yes. Okay, I think we can go to the next question, Stella. So most of you actually think that each parameter should be weighted, so we should give a different weight to more. We should basically weight more the most important parameters. Okay, thank you. Oops, there is a question which. Okay, perfect. So we are going back to the slides. The second criteria that we consider is data reliability. Data reliability is usually done by using the Toxar tool, which is a tool which assesses reliability based on the Clemish score, and it assigns data to 3 categories, which are reliable without restriction, reliable with restriction, or not reliable. There is also a 4th category in the original approach proposed by Clemish, which is not assignable, but this assessment should be made by direct consideration of the user. Next slide, please. This is how the Toxar tool looks like. It's an Excel spreadsheet in which the user is asked to insert information, several information on the ecotoxicological test. This information includes, for instance, information on the identification of the test substance, the characterization of the organisms if the test was done in vivo, the study design description, so whether the specific the study design is provided together with the study, but also the documentation of results and the plausibility of these results. Next slide, please. The same applies also, sorry, back. The same also applies for the in vitro evaluation of reliability as provided by the Toxar tool. There are more or less the same information which is required. Of course, since the test is conducted in vivo, there is no characterization of the study animals, but of the in place of this, there is the characterization of the test system. Okay, next question. So the main drawback of this approach is that it requires expert judgment, because it requires and it cannot be automatized because it requires the user to go to the study to provide answers in the Excel spreadsheet, and also to give some judgment based on the questions that are provided by the tool. However, what we found by looking at each requirement of this tool is that most of the requirements of this spreadsheet are already considered when evaluating the completeness criteria. Next slide, please. Specifically, what we saw is that all the information related to the physical chemical characterization before having the calculation of the score for the Toxar tool are basically the information which is required for the completeness score that Hubert presented to you. And when there are no specific templates related to to the physical chemical parameter which is required by the Toxar tool. This information is included in one or more of the templates. Moreover, this also applies for the ecotoxicological endpoints. So most of the information which is required by the Toxar tool is already included in the template. And what does this finding suggest is that what we found is that what we are assuming is that if data is sufficiently complete, it is also sufficiently reliable. Thus, in order to minimize the need for expert judgment, because if you remember, we want to have an approach which is as much as possible automatized, we decided to merge the two criteria, and we know that this is a strong assumption, as having a high completeness score also implies having a high reliability of data. So we can go to the next slide, which I think is there are some additional slide of question. We can foresee that here we will have some lot of comments from your side. So first question is whether do you agree with our conclusion that the criteria completeness and reliability can be merged for the sake of minimizing the need of expert judgment? Indeed, we as expected, most of you are a large, most of the audience, now we are 50% do not agree with this assumption, which we know it's a strong one. Oh, sorry, I was muted. No, as I was saying, as expected, many of you do not agree on our conclusion that we can merge the two criteria. Of course, this will need to be explained more into detail if to have a complete to look better whether we have this overlap between the two criteria or not. But we are happy to see that there is a large portion of you which instead agree with us that we can merge the two criteria for having in mind that we have the goal of minimizing the need of expert judgment. So we can go to the next question. Is there something that we did not consider for assessing data reliability? And this one is actually related, I think, with the previous question. So if you answer no, probably it's because something which is important in your opinion was not considered. A complete, well, this one is a good one. A complete data set does not mean a good data set. This can, in principle, it is true that complete one doesn't mean completeness does not mean good quality. We have two additional criteria that we will I will explain to you. I will show to you next, which hopefully will in our mind are increasing data. If considered, are more apps to understand whether quality is there or not. Yeah, of course, and this is what was mentioning before. If you want to demonstrate that completeness implies high completeness implies high reliability, we definitely need to do comparison and to see whether having whether it's true that having a high completeness implies a high reliability of data. Applying, of course, using not only looking at the characteristics, but also seeing whether there is this correspondence in the existing data. Critical review for each method. Yeah, so I think there are a lot of comments from your side, which will be a starting point for us for improving our approach and to see how to to decide how to proceed in the implementation and in the definition of the methodology. There was, yeah, there are. Thank you very much for your comments. I don't know if we can wait another few seconds so we can go to the slides, back to the slides. It's very difficult. This is based on very limited information, of course. Yeah, of course, this is true. It's not easy to have a judgment just by following a presentation in which we try to be as clear as possible without going too much into details. But of course, it's there are lot of things which are really specific and needs to be carefully evaluated and considered before accepting a methodology like this one. So thank you for your comments. That will be a very nice starting point for continuing our work and for refining our methodology. So the next criteria is data relevance, and this answer actually some of the comments that hopefully answer some of the comments that you provided in the slide or question. Data relevance covers the extent to which data and tests are appropriate for as a characterization, and basically it answers the following question: is the study conducted using protocols and procedures that are relevant? No, go back, please. No, back. Okay. No. 4 categories. We defined 4 categories for data relevance. The first category is comprises data which comes from international recognized standard guidelines, such as the OECD's test guidelines. The second category is we defined it as this data which were derived using nano-specific validated protocols and protocols that are candidates to become OECD testing guidelines or OECD testing guidelines with modifications. Then we have the third category, which is data for which the protocol is not included in the first 2 categories, including nano-specific protocols which are not yet validated. And category 4, which is data for which the adopted protocol was not reported by the user inserting the information in the database or in the scientific article. We proposed some scores. So we of course at category 1 such data which is derived using international recognized standard guidelines is the most relevant for risk assessment. The second one is a little bit more relevant, but we have second category which is not yet validated or sorry, nano-specific validated but not yet testing guidance are a little bit weighted a little bit more, so they have a little bit little score, but still high, still an high one. And then we have this category 3, which has a little score. Of course, what is important is that if one of the this is not a fixed scoring, because for instance, if the protocol, if a nano-specific protocol which is not yet validated becomes validated, say after 2 or 3 years, all the data in category 3 moves to category 2, for instance, and so increases the value. This step was partially automatized, let's say, but because in the or can be automatized because we have a predefined list of protocols while inserting data in a nanomapper, and so we can associate to each of these protocol the category and then the selected score. So thank you. We can go to the next slide. So here we have some other questions for you. First one, again, do you agree with the definition of the 4 data relevance categories? So category 1 is international data coming from internationally recognized protocols. Category 2 is data derived using nano-specific validated protocols. Category 3 is data which does not come from OECD testing guidelines or for nano-specific protocols. And category 4 is data for which the protocol has not been reported. So most of you seem to agree with us with the 4 categories that we defined. We can wait. Well, there are still people answering, so we can wait another few seconds and then move to the next question. Okay, thank you. If you answer no, please provide your proposal for changes. So scientific studies are excluded. This is not true because if you are you are defining a protocol, first of all, keep in mind that our goal is risk assessment. So it's important to have an information on which was the protocol, or at least which the design of the study. So if the study is well described, so data falls in category 3. So data not coming from international recognized protocol, validated protocols, or from protocols which are nano-specific but not yet standard. But of course, it is still considered. We are weighting 0 only data which is for which we don't have any information about how it is retrieved, basically. Is the focus on regulatory aspect? And yes, that's exactly the point. From literally same thing. If it is clearly stated which is the testing guidelines, we are categorizing it into category 1 or 2, otherwise not. And what about validated SOP which are not yet OECD test guidelines but provide reliable data? We are including it in category 2, so they are still considered as reliable but not as much as the OECD one. Some other testing guidelines were proposed, if I remember correctly, one of the first questions. If you can scroll down, please. So ISO, yeah, this is true. So together with OECD testing guidance, probably we will need to consider also these other internationally recognized standard guidelines. So not only the OECD ones, but also standard guidelines coming from other organization, for instance. So not also the ISO. Also, this one can be put in category 1. Of course, this is something that we need to consider. Yeah, so I think I addressed most of the question. We can go to the next one. Okay, data relevance depends on the purpose of the evaluation. So risk assessment, again, in our case, the scores are 1, so the most reliable one are for the international recognized standard guideline. Then we have a little bit more score, which is a little bit smaller for data coming from nano-specific validated protocol or SOPs. A little score for data which is not from validated protocols, and 0 for data for which the adopted protocol is not reported. Keep in mind again that the goal is risk assessment and specifically at this stage for regulatory purposes. So I think we can move to the next ones, which if you answer no, why are these scores not appropriate? Okay, so we have the factor for category 3 and 4 seems very low. For category 4, basically we are excluding all the data which do not include or do not specify which protocol is used. Nano-scientific studies are scored too low, even in case of risk assessment. But not only the 0.1 is are studies which are nano-specific and not validated. So let's say the one which are still under development, but of course, if they will be validated sooner or later, they will increase their score as they will go to category 2. Why specifically? This is a nice question. It was just to have we wanted to have a distinction, but of course these scores are not fixed. I mean, we of course some judgment will be needed in order to find in order to find the best scoring for each of the category. So also we can consider also increasing the scoring for studies which comes from not from validated protocol, let's say. Okay, the problem arises if the SOP is not validated, but there is no validated alternative. This is true, but of course, if you are when you look at the data, then you will have that this is the most quality data that you have if there are no validated alternatives, probably. Okay, list of accidental score. Yeah. For this is true for future reference. If category 4 equals 0, when it's better to remove it completely, promoting scientists to work at least with standard 3. Yes, but I mean the goal of this is like of having this category is to exclude everything which is not with the standard, since it is weighted 0. So we can just, in principle, we can just remove this category and say which is not in these 3 categories should be discarded. Is basically the same thing. If score 0.5, it's not possible because 0, 1, 0, okay, but to go back, you mean probably the question is by just looking at the score at the end to understand which category we have, and this is something which is probably not possible because at the end we are merging all the scores. Well, okay, yeah. Of course, what we will need to see, having in mind that the categorization seems to be accepted by most of you, is to understand how to weight this course. I think we have another question, but I'm not sure about that. Probably it was merged. No. Okay, perfect. Okay, so thank you again for your input, which will definitely will be definitely considered in the next steps of our work in order to refine our methodology. And so let's go to the final criteria that we considered, which is data adequacy. Adequacy defines the usefulness of data for the purpose of the analysis, which again is risk assessment. In our approach, higher weight is associated to the most reliable test for risk assessment purposes, which is in vivo, while lower weights are associated to in vitro and in silico studies. Why we do this? Because this is this first starts from one of the goals of our methodology, as you remember, which was to implement at least the initial version on a weight of evidence approach. And what we found in literature is that it is common to distinguish between in vivo, in vitro, and in silico studies. And this is something also which we found during the assessment of the Gracious project. In the most of the, I do not want to go too much into details, but for instance, in silico studies were considered only in one IATA or probably in no IATA at all, while usually the evaluation starts from the in vivo studies, and then if there is no in vivo data, you go to the in vitro one. So for this reason, we proposed different weights for the studies. So we proposed to score 1 the in vivo studies, 0.6 the in vitro ones, and 0.3 the in silico ones. And this is based on the study of which I'm referencing here. But of course, again, these weights can be changed or can be customized on in a specific case. So I think we can go to the next slide, which is again asking you to go to Slido to answer some questions. So do you agree with the proposed criteria for assessing data adequacy? So the distinguishing between if the data comes from an in vivo, in vitro, or in silico study? Yes or no? And again, I think we will have the question, but in this case separate. I don't remember. So thank you. it appears that most of you agree with us with the way in which we define the criteria, but again, there is consistent quantity of you which do not agree. So I think the most interesting part is to understand why do you agree or why you do not agree with us. So I think we can wait a few seconds more and then go to the next question. Okay, so okay, sorry. I think we have already. If you do agree with the criteria for data adequacy, are the proposed weights appropriate? Yes or not? I don't know if the answers were merged there. Probably something strange happened. Okay, if you do not agree with the proposed criteria, what other aspects should be considered in assessing data adequacy? So the okay, we already have the answer. Sorry, thank you. So can you please go back, Stella, to the next one, the previous result, in order to see. So the people which agree with the criteria for data adequacy, most of them agrees with the weights, and half and half, let's say, do not agree with it. So of course, this will need to be thoroughly discussed between us and also to be accepted by the community. So let's go to the next question again. Sorry, Stella. If you do not agree with the proposed criteria, what other aspects should be considered? Where would AI be in? So no AI, but automatization, because since again we can associate to each protocol. I mean, we can again associate to each protocol whether it comes from an in vivo or in vitro study, and then consequently automatically categorize the protocols and then the data into the different categories. Data is reliable or not, regardless of the source. OECD works on testing guidance. This one, I think, this one is for the previous one. In vitro and in silico approach is based or linked to in vivo studies. They should be more equally scored. This one, I think, no. This is an interesting point. I don't know if all the experts agree with that, because there are it has been seen that there can be difference between outcomes of in vivo and in vitro study, but this is a good point. I don't see the other value of expression. Sorry, Daniel, yeah.
Yeah, this is certainly a valid point. Obviously, we're moving in the direction of reducing animal testing, and in vitro and in silico data will eventually become more and more adequate for risk assessment. But obviously, this data need to be processed. To use in vitro data, you need to perform in vitro in vivo extrapolation. And this is processing of data to make it more adequate for the risk assessment. And then in silico would also probably become more adequate, but I would see that more for the future. Currently, I would not use in silico for risk assessment purposes.
Okay, thank you, Daniel. See, yeah, most live in vivo data means not automatic. So yeah, there are many comments from your side. Thank you about this, and which will be taken into consideration. Thank you again for your input. Inhalation does not require. Okay. So yeah, I think there are many things that can be okay. Okay, yeah. So probably we will need to take into consideration your inputs here and see whether we can increase the scores for in vitro and in silico studies. Thank you again for your inputs here, which very valuable, your very valuable inputs here. So should oh no, wait, this one is this one is probably for the oh no, okay, no, it's correct here. Sorry, Stella. Should additional criteria be considered, yes or no? And if yes, if I remember correctly, if yes, we are asking you which other criteria, if I remember correctly, should be considered. So we can wait a couple of seconds more in order to see if someone else answers. And I see that many of you, at least so far, think that the criteria that we consider are sufficient, but there is someone which believe that something is missing in our approach. So let's wait a little bit more and see which are their suggestions. Okay, thank you, Stella. I think we can move to the results. Okay, so additional weights depending on the characteristic of the in vitro, in vivo, in silico test. Degree of in vivo human validation of in vitro assay, complexity of in vitro assay is not necessarily a measure of predictive capacity. This one I think are more related to the adequacy criteria. This one is a nice point, is an interesting point, representativeness of the toxicological data to real life scenario. Criteria, okay, yeah, of course, this is true. The criteria needs to be improved. A linkage to adverse outcome pathways, thank you. This is something which maybe we can also consider. Allow users to rank the datasets and show the number of downloads of the dataset. I don't know if, yeah, this is another interesting point. I don't know if, okay, so I don't know if it is, it can be a good way to assessing data quality, to considering quality, the times that people downloaded the dataset, but of course this is an improvement of, can be an improvement of the Nanomapper database. Probably Nina will add something about this in their presentation, or can consider this suggestion. So thank you very much for your inputs again. So once we define the criteria, the methodology that we are proposing for data completeness and quality assessment, which is again tailored specifically to risk assessment, and takes into account the 4 identified criteria. How it works, we compute score in an automatic way for each criteria, and then we aggregate all the scores into a data quality and completeness score. At the current stage, we are weighting all the criteria the same, so it's a arithmetic average between the scores or the compute scores in the previous steps. The whole process can be automatized, highlighting data quality directly on the database user interface, for instance, or in the templates in case, especially in case of data completeness when uploading and downloading data from the database. Next slide, please. Data quality and completeness scores may then be assigned to a specific light in a traffic light system based on predefined thresholds, which of course will need to be decided, this threshold. So in order to have a green light when data is of high quality according to the 4 criteria, yellow light if data is of sufficient quality but needs further consideration to be used for the task of risk assessment, or red light in case of data of insufficient quality. Alternatively, one can prefer to have this score displayed in a continuous scale, using a continuous scale. So as you can see in the picture here, and actually as Nina will show you in the next presentation, this is the current implementation in which this is what currently was implemented in Nano Mapper. So we have a continuous scale for completeness, which is colored automatically colored from green to red, or from red to green. This, of course, can apply also in the final score. So next slide. So next slide, please, Stella. So let's go back to Slido again. The question is the traffic light system appropriate to indicate data quality? So to have predefined thresholds and to access data into green, yellow, and red categories according to these thresholds based on the quality. And the next question will be if you prefer to have it on a continuous scale. Okay, thank you. We can we can move to the next one. I think the answers will be more or less the same. Oh no, okay. So we have another one. I didn't remember about that. Should the data quality be highlighted by providing predefined threshold, or should be quality be indicated on a continuous scale? So this one is related actually to the previous one. So it's actually the same question basically. Sorry about that. So here we have how to say both the options are have the same votes more or less. So probably what we we'll have to consider is to provide both options. So actually, if we define if we provide it in a continuous scale, it is also easily possible for the user to have to fix predefined thresholds and to customize it, and to have at the end the traffic light system in place of just a continuous scale. So thank you again for your inputs. We can go back to the slide, I think. Yeah. So just an outline of what I just presented to you. We created a traffic light methodology for assessing data quality and completeness in the context of the Gracious project. This traffic light, as I said before, was just the last question, can be also be quality can also be displayed using a continuous scale, so not just a traffic light methodology. The approach is tailored for risk assessment purposes and focuses on physicochemical and ecotoxicological data. And the methodology has been partially implemented in a mapper database, and also on a weight of evidence approach that we developed during the context of the Gracious project. So thank you for your input. We have some final questions for you related to this presentation and in general to the methodology. I think there are three other questions. And thank you again for following this presentation and for your precious input. The first of this final question is whether you think that the methodology, which is currently tailored to risk assessment, and the selected criteria are appropriate for the scope, which is again a regulatory risk assessment, or not. So we can wait another 10 seconds and then move to the results. Okay, so please explain your replies. We have a yes, but we need to be aware of the many deficiencies, of course. Unfortunately, I do not see a better method moving forward. Hopefully, we will, starting from your comments, we will try to improve this methodology as much as possible. And of course, second comment, with limits, yes, there is at the moment valid and reliable data needed for a regulatory risk assessment. Threshold should be, I think, dependent on the context and regulation. A huge number of details need to be further elaborated, of course. This is just a general presentation, as I said before. The method moves from specific data completeness to being can you scroll down, Stella, please? No, down, not up. The method moves from specific data completeness to being an automatic of data interpretation, I feel, with many legal issues to consider as well as scientific. So yeah, we should be careful on it. It's a good starting point. However, further discussion is needed. I agree. And an extension of it, considering new approach methodologies and AOPs. Yes, of course. Thank you for this comment. Let's go at the beginning. Methodological topics I will find relevant. Nonetheless, I found that Excel is not the right way to implement it. the traffic light will probably not work in every version of Excel. Okay, thank you for this, and this is something probably that Nina can comment afterwards. But in principle, once the methodology is accepted, we can also have the same information directly in the database in principle. I don't know if it will be the case or not. Regulation is not the only activity that needs quality data on nanomaterials. Of course, this is an important thing to notice, to point out. But many of the criteria that we have are depend on the task. So it is already a task which is quite I mean, defining general criteria for a specific task, as we demonstrated during this workshop, is not easy to make everyone happy with a specific methodology. To have it in a general way, covering generic tasks, is even harder, and moreover even harder to do in such a way that is accepted by the community. Okay, thank you very much again for your really valuable inputs. I don't remember if there is a final question. Probably not. This was the okay. Is there something missing in this methodology? This is the very final question for you. Okay, thank you. Sorry. The big comment here I was saying is basically says that this is a good initiative and it's a good starting point, but the further discussion is needed. And indeed, what we plan to do in Go for Nano project is, starting from this methodology, try to improve it. And also the comments that you provided in Slido will be really precious for us to move forward with respect to the process that I just explained to you. We have not tied it to grouping, which was the gracious goal. Yeah, we were more we related it on risk assessment, but in our opinion, this can be also applied also. I mean, we need to see whether this applies or not to grouping. This is thank you for this comment. Validation sensitivity analysis. Yeah, Daniel, please.
In fact, I think it would apply also to grouping if the purpose of the grouping is risk assessment. So I don't see a reason why this methodology would not apply to grouping. And in fact, we also applied it to classification according to the COP regulation, and a paper was recently submitted. But we're behind schedule. So I really thank you for the many and really constructive comments. I'm very happy that there is a good level of acceptance of what we've been doing. I want to remind you that this methodology is based on criteria which have been established for more than 20 years and used in the context of regulatory risk assessment. We would take your comments very seriously, and we will do our best to address all of them in our further work. Now, I would like to introduce Nina, who would demonstrate to us how aspects of the methodology, especially the part related to data completeness, was implemented in the gracious Nanomapper database. And also maybe Nina would share some ideas of how other aspects could technically be implemented once they're further elaborated. Nina, the floor is yours.
Thank you very much, Daniel, and thank you for attending this webinar. I think there was already a pretty good discussion, and we'll be learning from your feedbacks for sure. So this was some early attempts of implementing the methodology, and not so much of implementing, but rather identifying the challenges and what is needed to be done in order to implement it. Next slide. Or should I move the slides myself? Yeah, I think so. Yes. So these are the criteria, which I'm not going to repeat. This whole session today was dedicated. And this is the latest publication of the Nanomapper database, which Hubert already mentioned it. This is a publication from May 2021 in Nature Nanotechnology. It describes the technical development for the last 5 years or so, but it also uses NanoRec2 project data as a case study, and also omics data as a case study for establishing, for checking fairness. And there's a huge set of collaborators from NanoRec2 project, which I think is the best way to go towards fairness by involving the community. This is an online website. We name it Nanosafety Data Interface, but this is also the data is also programmatically accessible. There's application programming interface where everybody could access the data in a programmatic way as well. And it's a large compilation of nanosafety data from more than 10 projects for more than 10 years scope range. And you could imagine that so many projects, so many organizations, and so much time, the data quality is how to say, not one and the same, let's say. And this is why we are really interested in having automatic methodology for accessing the data. Now, you have already, everybody is familiar with these days with the FAIR concept, and the idea of the FAIR is really reusability. It's not just putting a score on your data, but how this could be used by others, or even by yourself in sometime in the future. The first row is obviously illustrating the typical scientific workflow, where you have your measurements, your precious data, and then you have a paper, and that's it. Currently, we're trying to make this a bit more usable by data being put into a FAIR database with semi-automatic annotations, and trying to enable it to data science. So as I said, all the data could be automatically accessible. We have this workflow published in MDPA Nanomaterials from last year. There are a lot of technical details how this is being done. Now, back to the data completeness. What do you need to implement the completeness scores? We have this NanoRec and gracious templates, as Hubert was describing in the first part. These are for physical properties. There are also other templates for ecotox and toxicological studies. Very trivially, the first thing to have is to have a unified naming of fields across the project with ontology annotation. and for data which is already in the database or coming from multiple sources, we need some mapping between fields. We have, as I said, a workflow where we can do this. This is semi-automatic at the moment, and there was one of questions where AI comes in. AI might come in automatically mapping terminology from different sources, but we're not yet there. How we're currently trying to support the community with the templates. It's not just sufficient to have these templates published in a repository and having DOI assigned to them. These templates, which is the case of Nanorec and Gracious templates, the challenge is that people should actually apply these templates in a kind of rigid way, manner without modifying it at least too much, and having some controlled vocabularies when entering data, naming of materials, etc. For this reason, we introduced it last year, not only in Gracious, but in all projects using Nanomapper database, the so-called template wizard. This is a web form where we provide a lot of all of the available templates from developed by multiple projects. And you could download the template with the structure Hubert was showing, but it also includes a list of predefined materials particular project is working with, and also, for example, a list of SOPs, etc. This is, and then when you download, the template looks as was shown previously. It also could include a completeness score, so that you could have idea of your completeness score when you are entering the template. Another way of using the completeness scores or implementing in a database is not only when entering data, but when exporting data from existing data. We have this flexible faceted search where we could provide multiple criteria to filter data. And once the data is filtered, there is an export facility where you could select this particular type of export, and all the data coming filtered from the database will be automatically filled in this template and completeness score calculated. This was implemented in Gracious when we realized that Hubert team was spending a lot of time of manually copy pasting data into the templates. So this is one way of getting data from database and looking in the completeness. There was comments that Excel is not the right way to implement the completeness scores. I would actually agree, not for the reason that this traffic lights is not going to work in different version. I'm pretty sure it's going to work because this is a standard way of visualizing this since at least 10 years old Excel. But for the reason that this is not the most efficient way of looking for data completeness. At the moment, what is implemented is that you only see completeness when you export the data. But you probably are going to look for data for exporting the high quality data first. So the data completeness, it will be useful to have data completeness already calculated so that you could search, give me only the data with the completeness score above certain threshold or so. So there's a lot of prospective developments. I'm very happy to hear such a variety of comments today. Now, caveats for data completeness. As I already said, the ultimate goal of FAIR is reusability. But the FAIR itself, FAIR guiding principles itself, do not define quality at all. I don't think they can, because FAIR is pretty generic concept, domain independent and agnostic, so they refer to community standards. And it's explicitly stated in the FAIR guiding principle that the quality issues are not addressed, and they are delegated to community standards. Now here's the caveat, because community standards differ. But for example, even with the nanoreg templates, which are around since 2017, if I'm not wrong, it's not, and they have been quite widely distributed, at least within Nanosafety community. This is an example from a different project. We provided one of the FISCAM templates, and what you see in red and dark red are the comments of the partners of that project. Red means that the question about red is not sure why these columns are there. Do they provide anything useful information to be there? And the dark red is what this means. What we should have here. So it's I also completely agree with the comments that there is a need of community involvement to actually make this usable and acceptable. We're trying to work across several projects of nanosafety clusters for using these templates. They're using in a daily basis, but as you see, it's always there's always a way to improvement, making things more clear, or at least arriving at an agreement what is important to report for a particular experiment. Of course, if you go beyond FISCAM into toxicological studies, we have dose response templates which with different structures. They're way too complex because we have dose response blocks, and each template is of 3 or 4 sheets. So this is not yet addressed here. We of course could apply a similar scheme on completeness and checking which field is there or not there, but there are a lot more aspects of evaluating the reliability of the study, as somebody mentioned, interference or variability of replicates, etc. So this is something which is not even touched this methodology yet. Also, the community standards differ. This is an example from a recently published paper, not ours. Colleagues sent it to me recently. The proposed standard for minimum information reporting in bio-nano experimental literature. What is interesting here, they understand the need to have FISCAM characteristics in the bio-nano study, but look at what is required there. This is basically the value of the measurement itself, and compare this in nanoreg templates for each of these entries, like size or zeta potential. We have one template with several tens of columns. So this is completely different level of details compared, again, proposed community standard. This is something that really needs a wide community collaboration. As I said, we can check data completeness on data entry, providing some tools for the data provider to have an idea of the completeness score, or maybe further reliability scores when entering data. But we also could have data completeness and all the other scores in the database. They could be, and now there comes different options. They could be calculated once and forever, but this will mix cases when, for example, protocols being validated. They could be continuously updated, and the challenge is that somebody who extracted data with certain quality last month may find different results today. And as somebody already commented on the chat, on the questions in the previous session. They usually, probably they should be different flavors of completeness scores, customized for different reasons. So all these open questions, which we're looking how to implement, and will be informed by the feedback of this workshop. More open question is, of course, this was anticipated that data reliability is not the same as data completeness. On the extreme case, we could have complete data set with garbage in the templates. Well, so otherwise, maybe we could, in order to make things automatic, we could check the content of the entries, not just counting black cells, verify in certain way of correct values, etc. Also, data relevance is which definitely needs improvements. This was already discussed, so I'm not going to go into detail, but rather anticipate that this could be discussed now with the open discussion after this session. Also, something which I'm really interested in is how can we extend the data adequacy criteria beyond risk assessment, especially for modeling, because there could be different purposes of getting all this data in the database. So this is also something that needs to be discussed and obviously needs further development. This is all from my side at the moment, and I'm looking for the discussion with open discussion of this session, but also on this on the entire methodology. Thank you.
Oh, finally. I had a technical problem, so I couldn't take it from Nina. Nina, thank you very much for your excellent presentation. And now we're already slightly behind schedule, but I would like to open the floor for general discussions. Stella will unmute you, all of you, and we will be happy to take your questions.
Just to remind the audience, in order for you to be able to ask your questions and to speak, you should click on the unmute icon on your that you see next to your name, and you should be able to speak now.
Okay, I thought I raised my hand, but that doesn't seem to help. Can you hear me?
Yes, we can hear you.
Okay, this is Ottmar from the Helmholtz Center, Munich speaking. Well, great effort. Congratulations, guys. I realize how much work is going into that, and obviously we desperately need to kind of organize our vast amount of data, and this is a huge effort towards it. So congratulations on this. Now, as you have already indicated, Nina and all the others, there is a lot of issues, yeah, with this. And the earlier we address it, the better probably. And Nina, I mean, when you give scores and you give all the time scores here, so what you're trying, what will happen is psychology will ask people to be higher up in the score. So it's very likely that if people have a completeness score relatively low, that they think about how could I improve my completeness score without actually adding more information data. So I think we need to be able to early on, not in the earliest stage, yeah. As long as we do this in a protected environment, like in an EU project, everything is fine. But if you open it up to the general public, I think we need some kind of a regulatory measure to understand whether there's just labels or garbage put in except of real information. Is there any way you can foresee that this kind of quality control can be implemented on a semi-automated level or something? Yeah.
Ottmar, I think you're completely right. In fact, one of our goals is that through this methodology, we provide incentive to data owners for providing more complete data sets. So if they see that their data set blinks yellow or red, that should be an additional incentive for them to complete the data set and provide a more complete Excel sheet. But you're right that some data owners might decide to artificially increase their completeness. And we need to really think about how to prevent that.
I think this is a real concern. And thanks, Ottmar, for this first question. There are many ways to we could use different techniques to check if the values are real, compare with existing values for the same type of data in the data set, and etc. But of course, this is a real concern, and measures need to be taken.
Next question or observation.
Hello, Enrico Bay here. Can you hear me?
Yes, we hear you clearly.
Okay. So first, yeah, thanks for presentations, and yeah, maybe just maybe wasn't getting the whole picture. So I apologize if it would sound a bit ignorant when I'm asking. But first, an observation with regard to the completeness, relevance, and so on of data. I would say that I mean these issues are for generic for chemicals, and I would also say that in terms of assessing the data that is being used for risk assessment and the relevance and adequacy of it and so on, we have some experience, for example, in the chemical agency. I was wondering, some of it is even codified and in guidance. I was wondering how much that has actually been used and tried to be applied in this particular case. The second is also was wondering about this structures related to data. I understand the wish for, I mean, having the the colors, the semi-automated approach that supports maybe some of more automated tools of maybe searching the relevant data and so on. But of course, these are supporting tools for the risk assessment. I was rather clear that this weighing and so on represents a certain crowdsourcing of what might be acceptable from the experts. So to some degree, I refrained from even replying some of the questions because I don't consider myself expert in risk assessment. So couldn't really consider what way would be to put on one or another. But at the end, I would believe that there would be an expert assessment on the relevance of each of the particular data points being used, and rather data points, but let's say studies, data sets being applied, and not maybe rely too much on those semi-automated tools, which may kind of put us either to being lazy or maybe for being too cavalier about excluding the data that might not maybe fit our expectations. So in particular, the data that might be varying in terms of the or stating something different than maybe the other data is, there maybe should be some more specific considerations in terms of the adequacy and relevance. I agree in the completeness that there needs to be a certain amount of information behind. And on that, I'm now going to my last point and question, and that is with the templates. Is there a particular end game that you might as well be considering and maybe putting it out explicitly? For example, that the end game might as well be that the data provided in this would be on one hand sufficient, for example, or even included in the Euclid system, so it can really be completely utilized in a fair way with all the other data. So how is the link with the Euclid on one hand, or how is the link for all the underlying data? How is the link with the adequacy or sufficiency of the data that needs to be submitted in order to be accepted into the publication in a scientific journal, so that data is actually complete enough in order to be reproduced and therefore can actually be used to be published as such as well. Thank you.
I can reply to the first question, and I see that Nina is happy to reply to the second and to the third questions. Yes, we started this work with really comprehensive review of literature related to data quality assessment for risk assessment purposes, but also all the related guidance documents. So this was all taken into account in selecting the specific criteria that we selected, and I know that Hubert can confirm this.
Yes, yes, I can confirm what Anna said, and also there was these questions about the templates. So when developing a completeness score, we were relying on mostly on the what data should be reported on the results of the Nano project that developed within the project these templates. And as the Nanoreg project was about the regulation, safety assessment, regulatory safety assessment of nanomaterials, these templates were, let's say, represent a consensus among the project, which consisted of a big part of the nanosafety community of the researchers, but also regulators in the EC and beyond. So these were, we took these templates at best that was available and that had the widest consensus within the nanosafety community at the time currently. And the other templates were developed within the project in the spirit of the Nanoreg templates. So this is the basis of the completeness scores, and also the rather let's say limited completeness score was also true for the data that come from Nanoreg. So astonishingly, those data should have been reported using those templates. We did not take them out of the blue, so that's why it was a little surprise for this low completeness score. Yeah, and that's the thing, how this completeness scores were made. Yes. Maybe regarding the quality, that would be then, or the completeness that would be then required to publish something. This is another question, of course, and we do not answer. We cannot answer that now, but it will be certainly possibilities to look at that in the future. Of course. Thank you.
Yeah, maybe I'll start with the third question because I don't quite remember the second. Submission with Euclid and papers. I would like to say that the Nanomapper database have been aligned with the Euclid, at least the top level categories and the templates since the very start, because we have been using it for transforming input and output of Euclid in a project which is for chemical substances, as you might be aware. So the one thing I would like to say is these templates are more detailed than Euclid. So this is what the community in all these years have decided that they want to put in. Whether this is too much for regulatory purposes, maybe it will be very interesting to have a say on this. But there are a lot of more details in these templates than what is required by Euclid. For scientific paper submission, most of the journals these days are requiring some kind of fair data representation, which usually refers to the community for minimal standards of requirements, isotope, and something this is supported by the community. And here is what we have for this moment, some templates which have been developed by and supported by the community since, as Hubert says. Whether this is something that could be put on stone in a paper that this is what the community say and give it a name, maybe this is something we want to do. But yeah, for scientific paper, I think community standards are something that are required. For Euclid submission, I believe we have a superset of information required. Also, starting from the ECHA codified knowledge on data quality, I'm aware there is huge teams working on ECHA on this, and would be very and cleaning data, because we're seeing that data in rich dossiers are being cleaned over the years. It will be great to have some more detailed, maybe even codified knowledge in a computer applicable way. How do you clean data? Because this is what we do by ourselves as well. So it will be, yeah, I don't know whether this collaboration is possible, but certainly there are parallel efforts on cleaning data from the community and cleaning data once it's submitted in the dossiers. So obviously some kind of collaboration, or at least information would be great. And yeah, maybe you could remind the second question, or somebody who remembers could answer.
I do believe it was answered more or less. I mean, okay, by all of you. I appreciate all the comments, and thank you very much.
Thank you.
I think we can take one more question because we're now behind schedule. If there are no further questions, then I would like to thank you very much for your participation, your excellent and constructive comments. They have been most useful, and we'll certainly take them into account. What you can expect from us now is a short report summarizing the discussion and maybe even to some extent trying to respond to some of the comments that you shared with us today. Our next step would be to try to address each of the comments and further elaborate and improve our methodology. Gracious has been a really excellent project which generated amazing results, but unfortunately it will finish in a few months. So then we would take this work further in the Go for Nano project, which is another really key project addressing the topics of fair data and topics of data quality in the context of risk governance of nanotechnologies. Of course, all of this work we also expect to publish in a peer-reviewed journal, so a publication will follow. Thank you for your participation, and we'll be in touch. Goodbye.
Bye. Thank you.
Bye. Thank you.
Bye, everyone.
Bye. Bye.